Hello and welcome to our session on flexible factories, future-proofing automotive manufacturing. I'm Nick Holt, editor at AMS. Today we're going to look at, as we said there, making factories more flexible. And as OEMs and suppliers are adapting and changing their manufacturing operations to meet growing demand for electric vehicles, as we've seen over the last few days and across the last few years, actually, flexibility and adaptability are kind of key requirements for next generation production lines. We're seeing a number of approaches to achieving this. Now, they range from reconfiguring existing lines with flexible tooling, or right over to the other side to creating completely new modular cell-based approach coupled with multitasking automation. All of these solutions are being supported by new, more sophisticated hardware and also digital tools that enable better data management and capture, connectivity and transparency across the production processes. And also, these are the technological frameworks we're seeing that are now underpinning new developments in production operations. So to get some insights into this, I'm really pleased to be joined by two experts who have a wealth of experience in implementing flexible solutions. To begin with, Romain Herry, who's a Global Business Development Manager for Industrial Automation at Conductix-Wampfler. Romain has been responsible for business development, automation, industrial vehicle solutions at Conductix since 2020, and he coordinates system solutions for all product lines, AGV, AMR projects, as well as for those stakeholders who are in the design phase or optimization phase of their new vehicles. So plenty to go on there, and Romain, definitely in your ballpark this one. And also joining us is Cengiz Kizilkan. He's President of Global Sales Automation and Executive Director of Europe for Magswitch. He's been with Magswitch since 2012 and established the European subsidiary there in 2013. Now, he started his career as a proposal engineer, and he's gained a lot of experience in the area of body and white manufacturing and has over 20 years of experience in the industry, including assignments in China and the US with major OEMs and tier suppliers. So, gentlemen, we'll get started on this particularly interesting and dare I say it, fluid kind of topic that we're dealing with at the moment. As I mentioned at the beginning, and it's kind of a given now, but flexibility and adaptability are key requirements, as we said, or I said, for next generation plans. It's all you kind of hear OEMs and tier suppliers talking about at the moment. What do you see as the sort of drivers, broadly speaking, across the industry? What have your experience? What's the drivers and also the sort of challenges around this? Can I come to you first, Romain, on that one?
Yeah, sure. Well, as far as my experience is concerned, we address the topic by delivering a flexibility at the energy management side of things. It's very important when you have a plant to be capable of either having a design that is flexible in its operations, or a design of a plant that can be evolving throughout its life cycle. That's true both for the energy management side as well as for the data management. You've mentioned it. The digital side of the flexibility is important, and that could address safety data as well. So there comes the question of connecting the data to a backbone on the manufacturing plants, and we could reach radio solutions, reliable radio solutions, and safety radio solutions overall. So that would be my first entry point.
Mm-hmm. And going over to you, Cengiz, from Magswitch's point of view, what's your perspective on what those kind of challenges and drivers that we're seeing in the industry for flexibility?
Okay, as a driver, it's mainly really the increasing quantity of models per OEM. This is a wider variety of types of cars, which has increased in the past 15 years by 30%, is inquiring a flexibility in the manufacturing lines. On top of that, in the past 5 years, there's increasingly, of course, coming the variety in powertrain, from combustion engine towards electric vehicles. which is also, again, requiring from the facility itself the capability and flexibility of handling those types of powertrain. And the assembly lines are challenged with the drivetrain side, and body in white is challenged mainly on the model variety. And we are addressing this by our technology in using really single-sided clamping, which is enabling smaller UATs and increasing really higher flexibility in order to fulfill the requirement of manufacturing 6+ different models over one manufacturing line.
Yeah, and just going back to the point you made there, Cengiz, OEMs were at one point before we got into the EV transition period. If we look back a bit, they were challenged even by just the number of kind of iterations or options that they had available on vehicles on manufacturing lines. Anyway, they were trying to kind of simplify the process. In both of your experience, now we're really getting into the ramp up of electric vehicles, and obviously in many instances, this is in conjunction with continuing production of ICE and of things. Have you seen an even greater emphasis and demand and requirement for a speedy solution from your customers in that respect? Has that kind of moved up the priority list even further as a result of this kind of merging now of two kind of powertrain areas, two kind of sort of vehicle types? So come back to you, Romain, on that one.
Yeah, well, it used to be in the past that you had a single loop in a factory to have an entry point and a single exit point. This has been cut into parts where you find that AGVs nowadays take the benefits of smaller conveyors, which are specialized in various tasks. So depending on what you need to get as an output, you get more variety of output, as Cengiz mentioned. But you address also another topic, which is very important as far as flexibility is concerned, is the volumes. You may have like higher quantities of a type of manufacturing and a smaller quantity of another one. You may even want to mix that all together. So you may want your either conveyors or AGVs working together in a proper manner with the same power system, for example, while everything is moving around. So we definitely see that, and I mean volume variations in addition of options variations are both topic which impacts our supplies as sub-supplier, I would say.
Yeah, and it's definitely been exacerbated by, as you said there, if you've got two variations on completely different platforms and powertrains, that is quite a challenge from a logistical point of view as well as an assembly point of view. And going back to you, Cengiz, what's your view on that? Obviously, you were speaking a little bit about body in white earlier on, but I mean, in terms of new platforms coming through, the vehicle manufacturers are obviously designing a lot of dedicated EV platforms now at the same time as running those ICE platforms through their factories. Have you seen that kind of need for line reconfiguring, etc., that sort of thing?
Yeah, absolutely. Depending on the OEM and the volume of the new type of vehicles, I'm referring to EVs, it is in a certain amount of cases required to really run the EV also through the combustion engine lines, which is a complete different underbody structure and also a different material mix. Having said that, this provides challenges not only in handling and fixturing, but also in joining technology. Different material mixes require different joining technologies, riveting, clinching, and whatever you name. And on the other side, the traditional steel car body is requiring 92% spot welding. These are different technologies which you need, first of all, to be able to fit into one station, let's say. And different OEMs are addressing this differently. And the larger volume OEMs are building simply new lines for the dedicated platforms of vehicles with different derivatives including different brands even, in order to gain synergies and flex, as Romain said, the volumes from Model A to Model B as per market demand.
I know you kind of both have touched upon this a little bit already, but I mean, and this is kind of really back to your key core competencies, but what are the sort of technology enablers? I mean, we're discussing that you mentioned AGVs and AMRs, Romain. Are the other technology enablers different, a lot different, or becoming more different, or becoming more widely used in those kind of contexts now? Are they being more widely accepted and being deployed in perhaps areas that they haven't been before to meet this kind of flexibility demand?
Yeah, definitely. We even see very different situations with the same technology, like very old first-time AGVs that still are there for like after 10 or 12 years. And people are upgrading those AGVs, coming from battery swapping, manual swapping, to wireless charging, so that AGVs are much more autonomous. And so it's just a slight upgrading with a technology that is more speaking about nowadays, with old AGVs just being upgraded. But we have also new assembly lines where everything on the ground floor is just AMRs carrying chassis or powertrains, and in the same time you still have that traditional technology, which is the conveyor rails, and then you get the easy marriage assembly all together. So, I mean, AGVs and AMRs are everywhere, either just as an add-on to the assembly line or as a main driver to the assembly line. So yes, it's there, definitely.
Yeah. And going over to you, Cengiz, I mean, I know we've discussed this in the past. I mean, you mentioned there OEMs trying to run both electric vehicles of varying degrees of, whether they're hybrids or whether they're full battery electric vehicles, depending on the platforms. And we're still seeing a lot of sort of crossover platforms out there at the moment still being produced, and their internal combustion engines. And you mentioned body shop, trying to run those through on the same line, so framing, etc., all those, that kind of thing. So from your point of view, if you've got a body shop line that's existing, you can't change it, you can't throw it away. You've got to deal with multiple platforms, certainly in the short term as they work through. So in terms of like the tooling side of it, I know that's an area of expertise for you. So where are you seeing much more demand for kind of more versatile tooling, shall we say, in the sense of that they can get more out of the particular body shop, operating areas?
Yes, absolutely. If we are really looking at the body shop and the demand on flexibility down to a platform, I'm now exaggerating. If there would be a large tier one supplier producing body in whites for 3 completely different brands, he would love to use one manufacturing line in order to really get the most out of it. Having said that, this is also an area where we, especially with our expertise and with our technology, are working on the flexibility of on the hardware side in order to create modular and also flexible, reconfigurable tooling, and also on the gripper side, handling, is one of the pieces of the jigsaw puzzle we are really taking care of and addressing in order to go ahead one step further in the level of flexibility we are achieving. Already 10, 15, 20 years ago, there were flexible lines I've seen all across the world, able to produce 3 different platforms, so underbody, and 6 different upper bodies. So this is state of the art since 2 decades. And now the different drivetrains, the complete different underbody structure, and the different material mix is adding a new level of complexity and flexibility. And this is really something we are with multiple OEMs worldwide investigating in and creating solutions for. And this will be one of the biggest challenges in order to gain the biggest synergies in between the manufacturing of these multiple sites.
Just stepping back from the individual kind of systems and products that you're delivering, this might be a one-word answer to this, but I'd like you to elaborate a little bit more. In your view, is automation the key to this? Because in the past, I'll contextualize this a little bit. In the past, when I've spoken to some line managers, automation wasn't always a benefit to some lines, and it was always a variation on what was. It was just putting in robots, or automation didn't simply solve all the problems that they had. In some instances, it created more. Now we know that it's become much more sophisticated, and with the data and the management of it, and times are changing in the approach to it. But in your opinion, as I say, stepping back from your individual kind of competence areas, when you're working with OEMs and tier suppliers, do you see that automation is the key to this, or will be the key for this? Romain, yeah, sorry, yeah.
I would say so. I mean, it's difficult to answer a side of my activity because I mean we are involved in I would say parts of automation solutions to make it happen to whatever moves. And I mean, automation is quite wide as a word that could involve safety, how you handle the safety of the operators, how you make sure that the flexibility doesn't go against the safety. And automation can definitely help combine flexibility with safety. So to make it short, I would say that's one example of whereas safety is usually seen as an area where you have more constraints. With automation, you can bring flexibility along with safety, and there are lots of aspects of it.
Yeah, so it's releasing some of those constraints that they've had before. And going back to you, Cengiz, I mean, I know Body Shop is highly automated, so I can't think of one now that isn't. I'm sure there are some out there. But from your point of view, if you look at when you're visiting plants and clients, and you're discussing not just that particular one area, but you're looking at across, a particular whole line. Do you see that they are looking towards automation as the solution now? And are investing? It used to have to make I'm sure they still do have to make a very strong business case for automation in any of the plants. But is that business case being easier to make now in the terms of what the demands are and what the solutions it can deliver?
Absolutely, would be the short answer. And the longer answer is the problem of automation in the past was when you are increasing the level of automation, you are increasing the level of complexity. Very specialized and skilled persons were required in order to really set up lines, maintain lines, and so on and so forth. This is one aspect. Why there was also a little hesitation of what you just said before, Nick. These levels and complexities of automation became now, with the latest generation of available technologies, easier to handle, easier to understand, easier to integrate. There are a couple of areas which are still need improvement, like automatic guided vision systems. But having said that, a majority of the level of automation is now familiar to really everyone, and everyone is comfortable with it. Having said that, the automation, the easiest way of automation started in press shops, press automation. Then it went to body shop. And the last piece now, after paint shop, is really the final assembly, which is the highest complexity because of the highest logistic, the highest variety of parts, of small, big, large, fragile, and all this needs a reliable process. On the other side, Nick, the last 2 years, I think, shook up the industry quite a bit. The companies who had a high level of automation already installed were, let's say, able to continue even they had lockdowns, people were not showing up to work, and so on and so forth. And this, I believe, is now also driving even tier one suppliers towards automation, low-cost automation, let's call it, so easy to implement. And this is, I believe, a trend in the entire industry now.
Yeah, that's very interesting, because I mean we do get a slight sense of that, but it's sort of interesting to get it from you guys. Looking at this kind of approach that you're obviously working with clients, we reinforce that. Again, stepping back, in your experience, do you see variations in this approach and the application of the way they go about in making their systems more flexible? Is that influenced in any way by sort of locations or regions, or is it more about the product that they're producing?
Yeah, sure. I mean, regions would move at different pace. That's certainly not the same everywhere. Even in the same region, you have countries who have choices, because, as Cengiz mentioned, in the past, automation was complicated. So if countries where you had like a habit of automation, then you had lots of experts, and other countries, they were like maybe on more traditional applications. So we see various trends, various evolution speeds. There is no general rule, and we cannot say at all it's the same everywhere. It really depends even on each plant sometimes. So we see a lot of variation. So I mean, we have to be very flexible ourselves in this flexibility coming and keeping on coming. So I mean, we have to match the traditional ways of doing along with the flexible ones. So that's our flexibility.
And Cengiz, I mean, again, body shop, what's your view on that?
Yeah, so there were always differences in doing things, looking at different regions as well as different OEM, and the fact that the product architecture, so the vehicle, is completely different between the OEM, is not even enabling in a lot of cases to copy and paste one solution from one OEM to the other, because the product architecture, the tolerance chains, and all the joining sequences are not supporting it. And if you are having a very skilled maintenance and production team, really highly skilled, move from one facility, from one particular OEM who is using certain ways of doing things, move it to the next one, they will fail because of this, because of these big differences. And I don't think that this will go away. It will always be like that, driven also a lot by product architecture.
Yeah, it must be interesting as well. For you mentioned there, like, the architectures are different across, so you're having to adapt. But I would imagine in joint venture factories where they're running two different platforms through body shops, they need two body shops essentially to make that kind of work. So I just wanted to sort of draw on your experiences a little bit in the sense of modular production, flexible changes in design and layout of assembly in respect of the areas you're working in. Can you give examples of how these kind of things have been implemented and optimized in like a brownfield site, so an existing sort of plant? Have you got any examples of where it might just be one particular area in the plant where you've introduced something that's kind of fitted this need for greater flexibility? I mean, I'll come to you first, Romain, on that one.
Yeah, I was mentioning recently, like a factory and assembly plant where they had like old style AGVs, 10-year-olds, where I mean, people would wait for the end of the shift to offload the batteries manually with the trolley from the AGVs, and then plug them, quite heavy batteries actually, so they could replace the battery and the AGVs would go for another shift, and that would be a 2-shift factory. And we are moving them now to wireless charging, meaning that the people's time for stopping the batteries, hurting their back, pulling off the battery on the trolley, is spared for those people to to work on the automation side, actually, because these guys were automation guys taking care of the AGVs, and part of their job was just offloading batteries, plugging them, and this is not where they are qualified for. So that's quite a simple example. That's where the autonomy was very partial. Now it goes full autonomous. That's one example.
And over to you, Cengiz, on that one. Have you got like an example around a sort of body shop where you've kind of implemented something in a brownfield, like a legacy site?
Yeah. So it was, as you mentioned, the brownfield, and a completely new model was introduced. The old line was ripped off. Yeah. And the old line flexibility was 1+1, meaning in batch build, you can then reconfigure manually and so on the line outside of the cycle time and build the second model in quantity X, then put it back to 1. And the requirement was to increase now the flexibility of this line to 4 models on the given space. So no more space, but squeeze now manufacturing for 4 models into this special commodity, which was a body cell commodity. We have been able, together with the planning department of that particular customer, to come up with a solution, again, based on our technology, based on our experience, to get the flexibility up using the given space and do a random mix production for 4 different models. And the lines are running now. And these are things which will more and more come, I strongly believe, especially in the body sides, as we said, derivatives or closure area, which is requiring dedicated tooling, because you have a station wagon, you have a crossover, you have a cube, you have a limousine, and different platforms again. And this level will definitely increase from even 4 to 6 to 8 in the future.
And obviously, what you've installed there has to adapt all the time to meet, or to a certain extent. I mean, I'm assuming future-proofing completely is impossible. Just going back to a bit around kind of sort of smart technologies, smart autonomy. You know, we're sort of seeing this. We tend to think about from your side, Romain. We tend to see like the AGVs and the AMRs. The AGVs, the old ones, obviously we're used to seeing them moving around from a logistics point of view. But the AMRs, we're looking at more operational functionality. Is the technology there to do this across the assembly line now? I mean, we're seeing at the minute if we say the demand is around EV, then the volumes, relatively speaking, are still relatively low for that. But do you see that if manufacturers want to ramp up to the same kind of levels that they have with ICE production, is that kind of smart autonomous technology, i.e., and I'll come back to Cengiz on this as well. So multitasking equipment, whatever it might be, is that capability there, and is the capability within it, in your experience, to ramp up to those really high volumes?
Yeah, I would say it's part of the flexibility to be capable of facing quite a significant ramp up, and to adapt to the fact that it doesn't ramp up as scheduled. But yes, definitely. Well, the thing is, the ramping up could be subject to a change in design. So, I mean, you usually have the final target of how big the production will be, or how big the assembly line will be. So you initially design for that final goal. So you have the choice of either targeting that end goal as an initial design, or you ramp up more cautiously with a preliminary design that is then upgraded for further volumes. I could give you an example. Today, with our wireless charging technology, we are capable of addressing various types of AGVs, of batteries, voltages, or capacities. So, I mean, you can start with small AGVs and then have bigger AGVs. They would still be matching the inductive charging station. So it's not anymore a matter of I have this fixed design of charging. Now it's much more flexible. And yes, indeed, with this kind of wireless charging, you are very, very flexible.
And over to you on that one, Cengiz, because I know understanding like the materials handling technology you developed, but I know there's a need for adaptability for the tooling to be able to multitask, and I know that is part of the kind of physical side of that on your side. But is that a fact? Again, when we're looking at you're saying about the body shop, that example you gave was doing 4 models. It might move up to sort of 6 or even maybe 8 different models. If the footprints are smaller, and does the flexible technology, for want of a better word, was that be capable of meeting those kind of ramp up, that ramp up? Because we do know that ramping up is not simply just doing things faster. It's much more complex in factories, in production plants, in operation, depending on what they are, to do that effectively. Do you see the technology there from, like, let's say, a body shop side, to be able to increase that volume significantly?
I mean, again, coming back to the different material mixes, the answer to your question is yes, I see that being possible on the fixture side. So reconfigurable fixtures. Again, single-sided tooling is mandatory in my point of view, because you are gaining a lot of more access, reducing non-value added times. On the other side, the material mix also is complicating the situation because, again, of the joining technology. Yes, we have developed the Magswitch method, where we can also fixture aluminum panels to each other, or different material composites even clamp in a fixture together. This is possible. It still all depends on the availability of the joining technology in this particular station. Yeah. So the bottleneck to me, again, becomes the joining technology. You are increasing the non-evaluated times, because during one exchange of the car, let's say in this cell, you have in between changed the technologies from resistant spot welding steel to resistant spot welding aluminum, or to riveting, or to clinching, and all this on one robot. The tooling side we have under control.
Yeah.
Joining is becoming the bigger challenge.
Yeah, and it's interesting there. You mentioned you solve one problem and you end up with another in an area that's actually, spot welding has been one of those very efficient throughput pieces. If you think about it traditionally, it's been one of those. Apart from, obviously, say now the multi-material thing's thrown into the mix, that is creating more of a challenge. But in the past, traditionally, very fast, very reliable, very, very proven. Just wanted to get your views on looking at startup. If you look around, I'm not sure if you have any you've been working with any of them, but the new startups that are bringing in new platforms for electric vehicles, and we're seeing a few of them out there. A lot of them are moving into the commercial vehicle space. Very modular design, very modular approach. Do you see that they have more of an advantage in terms of being flexible compared to the established manufacturers? Because the established manufacturers have always looked for flexibility, just to some greater or lesser extent. It's not something that's never been on the agenda for them. It's just the fact that the situation is changing and the markets are changing. But do you see that the guys that are coming in don't have to worry about what they're going to do with robots or press shops or particular types of line? Do you think they have an advantage in this respect and can be leading the way in this kind of drive for flexibility?
Well, I would answer on that first, because I have, not that big an experience, so I'll be short on it. At least they have a big advantage, which is a lesser experience of problem solving, so of problems being met. So they are more free in their design spirits, and maybe more open to new ideas for, handling things all together. So I won't have more than that to say for those startup companies. But really, being free of mind for the design of flexible solutions with still quite lower volumes that you look at when you start up is really an advantage to start with.
And going back to you, Cengiz, because I know this is kind of the other side of the fence, in the sense of these people are starting from scratch, so they can put in a modular cellular approach to it. But obviously, you've worked in OEMs, and you've you've seen where, and you mentioned there are always constraints with existing facilities and things, but also they have a huge amount of engineering competence, skill, and experience in terms of what they want to do and how they can problem solve. So how do you see that? Do you see the way that the I call them startups. I mean, a lot of them have been around for quite some time now, but they're quite often promoting a much different approach to their manufacturing operation. Do you think that's going to lead the way? Do you think they have the advantage?
They definitely do have the advantage, and I can just underline what Romain said before. They have the advantage of not having these levels of standardizations set. With that hierarchy of people who are, like cooks in the kitchen. You have one chef, and if you have 5 chefs in the kitchen, the outcome is not that good. So the point is that these guys are looking at the references of applications you have successfully implemented somewhere and say, okay, this is working. This is reference enough for us. Let's go. There is no years and years and millions of cycles. You have to prove your equipment in a particular spot application. You show them, this is it. Here's the reference. Let's go and see, talk to the people. Is it working? Yes, it's working. Let's go for it. With all the advantages, yeah? And this is something you will not see easily in established OEM world, because they know exactly what they have. They have specifications thick like a phone book. Are there phone books existing even anymore?
Yeah, they do. Yeah. Some places.
Yeah, but and you have to follow. You have to stick to it. Yeah. And this is limiting a lot the potential of integrators of providing innovation.
So here's a question, just picking up on what you said there, Cengiz, and you as well, Romain. Given that this industry we work in is been built on standardization, and it's always striven for standardization because that's been a foundation, is now that standardization, or is that perhaps with the established guys, is that now an obstacle in some respects to this push for flexibility?
Well, I wouldn't say so, because when you speak in terms of electrical values, you still need the basics of electricity standardization. So electrical standards are still good to go. When you speak in terms of safety, and you find that automation, as we mentioned earlier, allows for the constraints of safety to be handled more easily, then we can have safety with flexibility. So the traditional standards remain. Of course, we have more and more standards, and this is where sometimes we can wonder, well, which standard is applicable when you go beyond the basics of electricity and safety. And then in the end, you have agreements between parties and assessments and responsibilities. So, I mean, the leadership of projects would be the most important of all within this realm of standardizations.
And over to you, Cengiz, what do you think?
So I believe that the standardization is a good thing, first of all, because it is helping the OEM to be redundant, and rolling stuff out which is proven and copy and paste. So that's a good thing. On the other side, there must be also room for improvement of the standard, of the written standard, which is there since 10, 20, 25 years and even longer. And that's where I believe the next generation of engineers will come to provision, will see the benefits, and will push innovation into these existing standards and ways of doing things. And this is why our slogan is changing the way things are done.
Yeah. Well, I know. Talking to you, it's an interesting paradox if you think about it in a way, because as I say, standardization is key, especially now. But also, it can actually be a real challenge when you're dealing with the variety. You both mentioned there the variety. We have a question here, probably on safer ground for you here. I'm not going to start getting philosophical about the industry. A question here from our audience. wanted to know if you're both finding a requirement to connect shop floor automated equipment to a wider data set further upstream of the supply chain than only at the shop floor, sort of MES level. So are you finding that you need to connect beyond the shop floor, essentially? I think that's the question.
I'll take that one. We do see requests. Honestly speaking, we don't see the full functionality of it, but we do really see requests for broader connectivity, which of course is connected to a backbone, which is going to the direction of the question. What goes in that is a wider bandwidth requirement for communicating to all the mobile equipment, and a more reliable request for that radio communication, or for whatever link is used. We also use carrier current solutions, and that is being requested more and more. So we see on our side a request for bigger bandwidth communication for all mobile equipment, and of course that would be assembled to an upper level, but I couldn't speak on that level.
Okay, and obviously Cengiz?
So I have been in several conversations and workshops concerning this subject, and on the hardware side, I do see the necessity of collecting information and comparing information, especially when you are a global OEM, for example. You are applying exactly the same body shop here in Germany, then in China, then in the US, building exactly the same thing with exactly the same setup. And you are experiencing issues with equipment which is running in the States, which is running in Germany, and which is running in China. But different issues, why is this power clamp in this station for this job not performing as good as all the others? Why is this robot taking longer for exactly the same thing than the robot on the other two sides? So in order to gain efficiency of the production lines and reduce downtime, I strongly believe that something above the manufacturing execution system should be there in order to really look at the data and learn from the data and improve.
Okay, I've got just time for probably one more quick question, and I'm going to direct it to you, Cengiz. Sorry, Romain. This one's picking up on something that Cengiz mentioned earlier about joining. So the question here is, do we see laser spot welding necessary in body shops for future flexibility? Is there capital cost an issue there, maybe?
So it's a difficult question to answer, because again, the future body shop will, as we said, be flexible, will cover more than steel, aluminum, even different materials, so which is already a limitation for the laser itself. On the other side, the laser has a great advantage because it comes with a way higher process time than conventional spot welding. It means you can make 4 to 5 laser spots or 1 weld gun spot. So this is something definitely is increasing the productivity, but at which costs and which limits to the flexibility. So I saw this already since 10 years as a great benefit. Again, accessibility, single-sided tooling would enhance this kind of technology definitely, and would increase the benefit.
Yeah, thanks. It's really interesting talking to you both, because obviously the flexibility thing is kind of built in, it's baked into what we're seeing now, and you've both highlighted sort of areas where it's growing and it's improving and where it can go to. So it's really, I really appreciate your inputs on that. We're just about out of time now, so I don't want to dare ask another question. I've got quite a lot here still in front of me, but perhaps for another time we'll cover off on that. But I just wanted to say thanks to both Cengiz and Romain for your time and your expertise. It's been great talking with you. Thanks to our audience for joining us today. We'll continue after a short break with a look at lightweighting, covering materials and processes. And if you want to stay tuned to have a detailed look at how we're transforming factories from ICE to EV production, that's a little later after the lightweighting session. And finishing off today's program, we've got a great interview with ZF's Senior Vice President of Operations for the Division of Electrified Powertrain Technology, Arno Gullerin, who's going to be sharing some great insights into how ZF have been transforming their production operations and in conjunction with their staff and the technologies. So with that, I'll just say thanks for joining us, and goodbye.